Additive manufacturing is technology turning manufacturing on its head. It's a smarter, faster way to produce, perfect for a small, ultra-efficient Singapore. Additive manufacturing in Singapore is spearheading industries like biomedical, design and building construction, precision engineering, electronics, aerospace and marine offshore, as well as clean technology.
What we're working on is developing new materials, new ways of printing, and designing these materials to suit your body part, and then training the doctors to put them back into your body.
AM can be used to make injection molds with conformal cooling channels, as well as low-volume customized jigs and fixtures.
We have already seen door brackets which has been 3D printed and have been used in the aeroplanes. We will also see fuel nozzles that will be used in the aircraft engines.
So an exciting development is development of hybrid technologies. This is a combination of both additive and subtractive-based technologies, such as milling. Solar panel and wind turbine are some of the emerging applications with AM in the clean technology sector. The water membrane is another very exciting area that's coming through. Additive manufacturing is a huge area of growth for the future, along with robotics and automation. In Budget 2016, the government announced the Industry Transformation Program. Additive manufacturing, automation, sensors, analytics, these will be the enablers.
AM is identified as a disruptive technology. It has the power to impact lives, businesses, and global economy. It is a game changer. The current market size is about 7 billion, and we should see this number triple by the year 2020 to 21 billion.
The AM ecosystem, as we see it, is made out of three main parts. Universities that are training students for working in the 3D industries and do research in corporations that do prototyping work, actual parts, and scale-down model to train people, and individuals that take advantage of the fact that 3D can do small quantity productions.
It's critical selecting the right applications that are technically feasible and economically viable, then having a workforce that is able to collaborate and innovate to create the new applications and solve the challenges.
We want to help companies translate their technologies into viable commercial solutions. We do this by partnerships, seeding capabilities, and skills training to position them well into the next industrial revolution. If you are interested to know more about AM and the new wave that's coming, come talk to us today.
The main mission of AAIS has been very clear from the start. That is the promotion of the aerospace industry here in Singapore. AAIS started in very uncertain circumstances for the aviation industry. 9/11 had just happened, followed by the Gulf War and the SARS pandemic. It was during this period of uncertainty that the industry decided that we had to develop a strategy. We had to come together, engage the various government agencies, and work out on a long-term strategy for the industry here in Singapore.
Embraer has decided to join AAIS to come together with all the players in the aerospace sector to harness our synergies and also to work towards the competitiveness of the industry.
So the reason that we joined was because we had started a new factory in Loyang specifically to be in the MRO aerospace activity. And we saw the AAIS as the way forward to be part of the community, and we have benefited tremendously from this association.
The most valuable activities that AAIS created for us is the engaging platforms that enables us to bring our collective voice of the policy changes and all the market changes that may come our way.
With the aerospace industry transformation map, AAIS is committed to be the industry voice, helping businesses and engendering community. Let us continue this legacy and draw on our collective energies to build an association that is an asset for all of us.
Flair Dynamics is a Singapore aerospace precision engineering company. We provide business-to-business bespoke turnkey drone solutions. And actually at Flair Dynamics, we believe that the purpose creates the machine, So for example, like the Discrete Eye Micro Unmanned Aerial System is currently used in law enforcement as well as defense industries for means of tactical covert operations.
Good afternoon, all. I know it's just past lunchtime, and so you may want to just grab yourself a cup of coffee or tea to perk yourself up. But let me introduce myself. My name is Mahendran Reddy. I'm the head of ecosystem at the National Additive Manufacturing Innovation Cluster, also known as NAMIC. So as part of NAMIC's open grant call for parts analysis and design for AM program, NAMIC is hosting a series of meetings or webinars in collaboration with various trade associations to encourage the use of AM technologies for local SMEs across various industries, such as aerospace, maritime, semiconductor, precision engineering. For those of you who are interested in this program, we will be hearing more about it from our speakers quite shortly. Now, back to our agenda. We will first begin the session with opening remarks from Mr. Siao Keng Yeoh, Chief Executive of the Association of Aerospace Industries, Singapore. Next up, we will have NAMIC's Mr. Mark Lee, Senior Commercialization Manager, who will be detailing the 3D printing parts selection program. Following Mark, we will kick off the sharing by the companies on how businesses can benefit from on-demand materialization with distributed manufacturing enabled by additive manufacturing. First up, we'll have a sharing by ST Engineering by Dr. Tseng Guoying, Director of the AM Development Center in ST Engineering. Next would be Mr. Chai Haunan, who will share the perspective of Additive Flight Solutions as the company's general manager. Lastly, we will end our sharing with Mr. Lu Weiyao, the founder and technical director of Flare Dynamics. To round up today's session, we will be holding a 20-minute panel discussion and question and answer session where you can ask our speakers some questions via the Q&A box below. You can input your questions at any point in time throughout the webinar, so please don't be shy, just put it in. As we all know by now, the COVID-19 pandemic has heavily impacted many industries, with aerospace taking one of the biggest hits. Traveling and flights reached an all-time low, and there is a dire need for new strategies to repivot the business. In this virtual webinar, we will be introducing an AM Digital initiative to support companies to create digital warehouses and rethink how businesses can benefit from on-demand materialization with distributed manufacturing enabled by AM. We hope that our speakers' inputs would be able to help you understand the value of additive manufacturing technologies and an on-demand distributed manufacturing. So stay tuned as our speakers share how AM can possibly transform the aerospace industry as it recovers from the pandemic. Without further ado, let's welcome Mr. Sia Keng Yok, the Chief Executive of the Association of Aerospace Industry Singapore. I believe most of us here are very familiar with AAIS, which is a non-profit corporate membership organization representing the aerospace industry in Singapore. Mr. Sia serves on the advisory board of the Singapore Institute of Aerospace Engineers and the Singapore Space and Technology Association. He's also a senior member of the Institute of Engineers, sitting on the Aerospace Engineering Technical Committee. With his expertise in this field, I believe there is no better man to shed some light on the aerospace landscape in Singapore than Mr. Sia himself. Mr. Sia, welcome, and over to you.
Thank you, Mahendran, for that warm and kind introduction. I'd like to thank NAMIC for the wonderful collaboration that we've enjoyed coming to past 3 years now. And you know, it's something that has enriched the aerospace sector as we look to new technologies to create opportunities for the future. Now, the AAIS vision is to be an innovative aerospace community for a sustainable future. And so the whole subject of additive manufacturing is very much within the interests of the association. I see our role as this, you know, even as the first movers push the frontiers of applications in AM, what we can do as an association is to support the development of the whole ecosystem around it, right? So address the opportunities arising, identify the gaps, strengthen the ecosystem, and uplift the entire sector. Now, aviation application of additive manufacturing has been, shall we say, stepwise, right? We're quite a conservative industry because aviation safety is always top priority. And we view sometimes new technologies with a little bit of healthy skepticism, but that enables us to you know, ensure that we've covered all our bases before we place new technology on board an aircraft. So despite this very cautious approach, we are seeing AM increasingly in aerospace applications. And in fact, I can bravely say that it is inevitable, right? And the three speakers today have interesting things to share with all of us about the progress they've made applying AM technologies in their businesses. And every time I hear speakers like them share about it, I'm really excited because I can see the progress taking place. And I'm sure you will feel the same way at the end of today's session as well. In particular, you know, I'm delighted that NAMIC is taking this step to launch an open grant call, which I hope will accelerate the adoption of AM even further, helping more companies to strategize about it as part of their business, and importantly, to explore and to experience it for themselves, right? We need to prove it in some way before we figure out, you know, how this is going to help us develop the business opportunities further. So without taking up too much more time, I really like to hand the time back to Mahendran and wish everyone a very interesting webinar. I will also see you again during the panel discussion. Okay, bye.
Thank you, Mr. Sia, for that thoughts and kind words as well. So for those of you who are interested in our open grant call for parts analysis and design for AM program, get ready to start taking notes. Our next speaker is Mr. Mark Lee, Senior Commercialization Manager at NAMIC. So over here at NAMIC, we are a national initiative for catalyzing innovation and scaling industry adoption of additive manufacturing technologies. Mark concurrently leads the industry consortia cluster of the APEC ASTM Center of Excellence as well. And before that, Mark had spent over 10 years with the Forbes Global 2000 company with various portfolios from technology management, project management, marketing. He was a materials engineering graduate and has held engineering roles in aerospace company from the Fortune 500 list of companies during his early career. All right, Mark, please tell us more about the program. We are all ears. Over to you, Mark.
Thank you, Mahendran. Give me a second while I switch over. All right, so thank you everyone for your time this afternoon. So I'm very happy to be here. Just a short introduction. I'm Mark. I'm the commercialization manager from NAMIC, as well as the sector lead for aerospace, defense, and land transport sectors. I'll be running through a bit of our corporate deck, as well as elaborate on the new upcoming program to help enterprises in the aerospace sector. So we have the following three agendas. As mentioned earlier, this what we'll be running through. And a little bit of background about NAMIC. So we are the National AM Accelerator Platform funded by the National Research Foundation in partnership with EDB and Enterprise Singapore, as well as A-Star. We are hosted by Intuitive, the commercialization arm of NTU. And NAMIC seeks to help the industries be competitive through making various strategic plans for the future of manufacturing and pushing public-private collaborations. So this is done through nurturing and expanding the AM ecosystem, creating platforms to test and implement new business models and growth, while also accelerating AM standards creation. So being a business regional center and transshipment hub, Singapore will need to build a global ecosystem for the research and industry players to develop AM and to establish synergies with our partners, bringing in new companies that can value add to our industry. So as part of the technology translation and industry applications, NAMIC actually helps to mature this technology from anything as upstream as software and design optimization to materials characterization, over to even process and equipment characterization and post-processing process development. And standards development is also another area which is strategic for the domains of this relatively new technology. And it's only through standards development where the demands by the end users will increase correspondingly with the increase in the supply side of the house. So the following are some of the achievements that we have seen over our past 5 years of development. So NAMIC has engaged in multiple industry partnerships, and the main aim is to coordinate and translate such public sector R&D efforts into commercial applications. So basically to scale up the industrial adoption and to build the entire AM ecosystem. So following are some of the AM adoptions which are gaining momentum in Singapore. So on the top left, you can see some of the Sembcorp Marine parts with where they announced about 100 parts to be AM produced for vessels and offshore rigs. Ivaldi and Wilhelmsen Ship Services have announced that through AM they could reduce the lead time for spares. MPA and PSA on the Port AM facility, which has been an extremely successful and very encouraging response on the phase 2 of the JIP that has been announced recently. Then on the aerospace side of the house, so Collins Aerospace have announced that they have an EM Center of Innovation over in Changi. That was last year. And our partners at ST Engineering have made a great achievement in gaining the EASA supplemental type certificate for AM of aircraft cabin parts. So this is really credits to Dr. Cheng and her team on that. And for Additive Flight Solutions, which is the JV between Stratasys and SIEC, credits to Hao Nan and Stefan on achieving the AS9100D certification over in 2020. So up next, I'll be doing some elaboration on examples of the AM that's been applied in the end use, especially in the aerospace sector. So, so I'm taking a leaf from the recent announcement from Boom Supersonic. So NAMIC was not involved in this project, but I think there's some very valuable points to the future of aerospace engineering and aviation travel. So Boom is a commercial company. They aim to put jet consumer flight back into business again. Ultimately, they aim to schedule commercial supersonic travel by end of the decade. So the jet will be called Overture, includes a carbon composite airframe with the use of very efficient Rolls-Royce jet engines that's being, where afterburners are actually not being used during the supersonic cruise. So this is quite a feat. And recently they have announced the successful launch of the XB1, which was over in October 2020. The platform actually allows designers to explore numerous advanced design and manufacturing technologies other than the legacy ones. So AM or additive manufacturing could produce most, at least all these very extremely complex parts. And the XB1 actually has a total of 340 unique 3D printed parts. And the combined reduced weight reduction on this is actually extremely substantial. So I will be doing an elaboration on some of the parts which has been AM produced, largely on the laser powder bed fusion to produce quite a number of the titanium components in some of the even critical areas of the plane. So some examples would be the engine manifolds for the variable bypass valve, the VBV for short, that routes air release by the engine compressor to the aircraft's outer mold line. Then there's the exit louvers for the environmental control system, or people call it ECS for short, that cools the cockpit and the systems bay. So these louvers actually direct the center inlet's secondary bleed flow to the outer mold line. And third from the left that you see on the pictures is actually, the knuckle ducts on the extreme left, and also two diverter flange parts are frequently used in high-speed aircrafts to actually capture external air to cool the engine bays without affecting the aerodynamic capabilities of the aircraft. So the design concept for the aircraft generally starts with extremely aerodynamic profiles, following by trimming, filleting, and thickening of surfaces to increase rigidity. So these complex geometries actually create a perfect candidate for fabrication through AM. And this, of course, creates the other benefits of weight reduction. So one other factor about why some traditional methods couldn't be used for titanium parts is that titanium parts could be machined, but because most of these components are extremely thin wall, so the traditional methods of casting would not be that applicable, and it will be extremely increased in the weight, despite having the thin walls wouldn't be possible, basically. And that being the case, this is actually the next driving cause factor why titanium 3D printing would result in a close to a ratio of 1 on the buy to fly ratio. So next, I'll touch on some of the examples of tooling used in the Boom Supersonics case. So in Boom's hangar, there's actually quite a number of Fortis machines from Stratasys. So there's the 900 series, there's the 450, taking the center stage. And the F900 actually prints materials including the Altem 9085 and 9085 CG. Both materials are flame retardant, extremely high performance resin thermoplastics with high strength to weight ratios, extremely good heat resistance and high impact strength. So the Boom team actually uses 9085 for drill jigs that you can see on the third picture on the left. And also 9085 CG for the aircraft parts, on the end-use parts, because this 9085 CG comes complete with conformance certificates for process control and traceability. So the Fortis 450 actually prints a wide range of materials, such as FDM, nylon 12, CF, impregnated with carbon fiber. So during the build of XB1's fuselage, actually several hundreds of drill blocks were printed overnight. So this overnight printing actually saves weeks of fabrication time, and it had to be, if it had to be fabricated over aluminum easily for each drill block, probably sets you back by 3 weeks. But if you're doing it with FDM on these highly precise nylon blocks, it only takes like a matter of 1 or 2 days. And not only does it build up on speed, but it reduces the downtime for the entire assembly team. And on the top left, if you're able to see that photograph, let me see if I could zoom in. Okay, so on the top left, you could actually see the 3D printed prototype latch mechanism for the canopy opening. So this is to ensure that the kinematics actually meet the specifications. And in the middle, we could see the engineer drilling into the fuselage using, sorry, it's the wrong picture. So it's the engineer actually drilling in using 3D printed drill blocks as templates, and this greatly reduces the assembly time. And the last picture on the right is you actually see a jig that's being produced to check on the fitting of the entire engine. So this is one of the many iterations that the engineers have to use to ensure that there will be a correct fitting, rather than figuring out how to assemble it properly into the fuselage of the aircraft. So next I will be touching on the parts analysis and design for AM grant call. So the program will be, what you see here on the left will be the 2 phases for the open grant call for part selection. The main goal is for small medium enterprises to experience AM and to be able to equip them with this added value and added skill to this tool set, in fact, to help in some of the operations, be it for toolings or be it for end-use parts. So the grant call will start in June, where the interested SME companies could come forward with their list of parts, which they intend to have 3D printed. So we will be working with the NAMIC hub teams at the 3 STEM universities, NUS, NTU, and SUTD. So the technical teams will be using software to analyze these parts to assess printability. So once the parts have been analyzed, they will move to phase 2. And the SMEs will be working with a 3D printing service bureau to get the parts analyzed on the total process costs, from printing costs to post-processing, and performing some market survey on, let's say, on the part demands and what are possible processes, possible options as well. So phase 2 will be co-funded by Enterprise Singapore. So some details on the grant application. The main applicant for the grant will need to be a local SME with a legal entity and presence in Singapore of enterprise size. So all of the work will be performed in Singapore. So in phase one, the work will be supported solely by the NAMIC Tech Technology Hubs at the 3 STEM universities. And phase two, it will be co-supported by Enterprise Singapore through the EDG scheme. The end user company will be the lead applicant. So the total qualifying cost will be kept at 40,000 per project. And if the proposal is submitted before 31st March 2022, up to 80% funding will be available. If it's beyond 31st March 2022, it will be 70% of the qualifying cost being defrayed by EDG. So the applications will open on 1st June 2021, and all applications will close by 30th June 2022. So proposals are to be submitted through the NAMIC info email. For clarifications on the program, you could contact my colleague, Ms. Tan Hui Chi, at the email below. And also you are able to contact our colleague at Enterprise Singapore if it's with relations to the EDG grant in detail. So with that, I come to the end of my presentation, and thank you everyone.
Mark, thanks so much for sharing on our program that's being launched. For those of you who are interested in finding out a little bit more, we'll leave the necessary contact details in the chat box below, and you can contact us. So let's now move on to the sharings by the various companies and speakers we've lined up for you. First up, we have invited Dr. Tseng Guoying from ST Engineering. Dr. Tseng is the Director of Additive Manufacturing Development Center at ST Engineering, a global technology, defense, and engineering group with a diverse portfolio of businesses across the aerospace, smart city, defense, and public security segments. She leads the capability and business development of additive manufacturing for ST Engineering, and she set up AMDC in 2018 with her management's support. She also drives various collaborations that are relevant to AM with the aim to deepen the group's capability and expand its AM solutions and services. On top of that, Dr. Tseng is a member of the Singapore Additive Manufacturing Technical Committee and contributes to the development of performance standards for industrial additive manufacturing across Singapore. Now, I can see that Dr. Tseng is deeply involved in the AM space, and I'm sure she's prepared a lot of intriguing insights for us, Dr. Tseng. So let's welcome Dr. Tseng. Over to you, Dr. Tseng.
Thank you, Mahendra. Let me set up my slide.
Sure.
Good afternoon, everybody. Welcome to participate this event. First of all, I should thank NAMIC and the AAIS to invite ST Engineering to participate in this event to share our experience. We hope through this sharing, we can invite more applications, especially in aerospace industry. We are looking forward to have more collaborators, partners to bring our country level capabilities to next level. So my topic today is that we have additive manufacturing parts solutions which are ready for distributed manufacturing. If you have watched the video previously displayed, that will give us a very clear picture of our vision. Okay, come to additive manufacturing. The value proposition is very attractive. It's a long list. I'm not going to read through every line. I just want to highlight the commonly perception is that disruptive bring by the additive manufacturing, especially in supply chain, which break the current way of doing it. However, we can do it just by printing the digital file from the clouds anywhere in the world and at any time when we need it. So that's the huge change in the current supply chain. So how can we realize this kind of value proposition in our real world application? Then with this kind of desire, we started our journey in 2015. But then we purchased the industry grids printers. And after that, we started to look into how do we do certification. 2017, we obtained the 4th YASA certification with the authorization to print tertiary parts. So we expanded our DOA and the POA into that area by doing such work on the FDM machine. So with that, we started our journey we printed the first part, make the first appearance in the aircraft operation environment. So which start with an issue which is shared by our customer. There's a very frequent break parts, even during the installation. So with our engineering knowledge, we understand where is the root cause. Then we eliminate the manufacturing constraints posed by the previous manufacturing method. Instead, we are using the additive manufacturer advantage to change the features which cause the stress concentration, eventually lead to the break. So with this, we are able to bring down the previous stress to less than half. With this, we move on to printing strategy. How should we print it effectively with the lowest cost possible? So finally, we have the parts completed. We did the verification by the load test to making sure the design intent has been achieved. Finally, we bring the parts to the aircraft, install in the aircraft in June 2018. So the results is that we observe significant prolonged operation life and less interruption to the operations. Obviously, we can do supply on demand because we already have this digital file in our library. So this is the very starting example. With this, we concluded our value proposition. We suggested to our customers, we have two big areas. If you look at this summarized circle, the top ones we are talking about engineering value add to additive manufacturing. So where we are able to turn frequent failure parts to a more sustainable parts with the customization and the complexity incorporated with little or no cost, as well as we are able to consolidate parts, reduced weight. In the operational side, additive manufacturing has already presented the advantage as alternative solution to obsolete parts, long lead time parts, so which is able to rarely supply on demand. It's a big advantage to the operational support. So this actually we built in the value add through our engineering expertise, accumulated not only the MRO services, as well as our engineering R&D experiences. Together with our certification framework, we are able to attain EASA, CES, as well as FAA certification. So that will allow us to provide a solution to our customers for their performance excellence. So today, in terms of the hardware and system capabilities, we already have 3 systems which has been qualified, accepted with the EASA and the CES. We have a metal solutions, we have polymer solutions by powder, as well as filament. So in the pipeline, we are looking into the largest powder fusion system for metal printing, as well as open source FDM solutions, which give us variety and opportunity of low-cost printing to benefit our customers. All these capabilities is underpinned by our engineering capabilities, where we have created our proprietary processors specifications for the various AM processors, which are already accepted by both EASA and CES, as well as FAA. So we also created our procedures to control design and the production interfaces to ensure the quality assurance has been achieved. We also acquire our software suite, which enable us to do the reverse engineering, design, topology optimization, all the way to the printing design. So we are able to control the printing file in the cloud. Whichever qualified vendors, they can just download the printing file, directly print it as feature in the video. Behind this, we also integrate the workflow from the R&D all the way to commercial product. This to gauge the evolving of the AM development, as well as the market, the acceptance. Beside aerospace grades, in our family, we also have other 2 machines. One is the powder bed fusion, US M280, printing different materials, where we're printing the Pratt & Whitney flange. The other one is the warm machine, which is able to print very large part, up to 2.5 meters. Currently, we are printing aluminum alloy and steel. Through our journey, we have learned printing is not completion solution. We have to build our value chain, which bring our customer finished product. So this slides summarizes all the steps to take us through all the process to reach a final product, starting from the past design, where it's engineering know-how, to design for additive manufacturing. After that is the printing element. We need to understand how to print it, not only for the performance, but also for economics. Then from there, we carry out the post-processing, finish the parts as customer desired. Finally, we do the verification and the certification together to bring the parts to the aircraft. So this basically consists of three big elements, which is a design portion and the production process, as well as the post-process plus the part certification. So with this kind of capabilities, we are able to serve our customer as one-stop solution. Obviously, this cannot do without our supply chain. I'm going to mention about calibrators later. So today we have obtained the YASA certification, as Mark mentioned, which is the supplemental type certification for aircraft parts, as well as FAA PMA certification for cabin parts. So in this matrix, we're basically showing the capabilities we are able to offer for the AM parts certification in accordance of our in-house defined AM processors specifications. In summary, our capabilities today is actually stands somewhere here. We are able to offer 3 systems with the qualified materials, produce loaded secondary structure parts, which is not safety critical, directly for aircraft use. We have authorization under the YASA systems to approve and manufacturing such parts. We also have the authorization from the FAA on the PMA cabin parts. So looking forward, we are adding more capabilities, except the machine highly mentioned. We also look into the repair capabilities and more materials and more process capabilities, which allow us to provide cost-effective solutions as well as more critical parts. So we have already established our website. If you have time, I would like to invite you to visit our website to find more details. Along this way, we do deliver different parts for aircraft operations. So I have to thank NAMIC. This journey, we actually have a strong support from NAMIC as well as the clusters of NAMIC. Without them, we are not able to achieve this kind of results within this kind of time frame. So I would like to share a few completed projects to give everybody a feel. Then you probably have an idea how this can be done. So the first one is the aeromedical equipment. It's on the A330 aircraft. What is the requirement over here is 3 types of air ambulance equipment for for the patient rescue purpose. You can see there's ventilators and others. So the requirement is that during the operation, the stretcher will be here, the patient will be right down here. So the doctor will be around this area to carry out the duty. So in our design, we need to maximize the space for the doctor. To achieve that, actually you can see all the 3 equipments is being pushed back. It's a flush with this plane. So in that way, we have the largest space for the patient as well as the doctor. In second place, we actually make the line of sight and the same height. You can see these 3 equipment of different sizes. In order to make the line of sight the same height, make the observer easier to monitor the patient's situation, we vary the design of the mounts. We also incorporated the quick release toolless kind of feature, which allowed the operators to set up and remove the mount as well as the equipment within 30 seconds to suit for the emergency situation. Then after this kind of a design constellation, we carry out the topology optimization, starting from this kind of design. Then finally, you can see the right. Okay, that's the final design. We conform with the loads and stress analysis. Then we perform the fitness installation review with the customer with 3D printed prototypes. That actually gives very good feel from the customer, expedite the project movement. After that, we study how to print the parts, nested them together for the performance, quality, as well as together with the witness coupons. So after all this printing, we assemble them, post-process them. Finally, we carry out the proof load test. You can see that the pink color, the orange color is the mount which we use for the test. So finally, we put onto the aircraft. So something here I would like to highlight is that you can see the organic design of the 3 mounts. We have this shape, V shape, is incorporated to all the design, which give opportunity for the operators to put their hands right behind the equipment, facilitate for the removal and installation, because the largest part is over 13 kg. For conventional method, this kind of construction is going to introduce extra costs. So as a result, we actually introduced the cage design. You can see this kind of cage design, which hug the equipment. There's no direct connection to the equipment. So give a lot of freedom what kind of equipment you are able to bring onto the aircraft. At the same time, through the topology optimization, we make it lightweight. So it's about 20% of the payload weight of the structure. So this is one of the example. The next one I want to introduce the cabin parts is certified by the FAA PMA. So this part started with the issue. You can see that actually it's a frequent break parts. With our knowledge, we understand the issue. We keep the exterior look identical, however, we change the internal design. So by this change, the stress level dropped from 50-something megapascal to 20-something megapascal. So it's a significant improvement of the durability of the part. Then after that, we study how to print it for the statistics, because this on the armrest have direct contact with passengers that have direct impact to the airline's image. So we study different orientations without compromise the part performance. Finally, we select one of them. As Mark shared before, we also use 3D printing to create jigs to do the quality control. Such parts has very complex contour, very difficult to do physical measurements. So we are using the 3D printed tools to check the quality, to making sure the consistency and meeting the customer's requirement. This picture is showing the certification test using Abius Lutz as per the requirement. So all the parts, the 4 parts, passed the Abius Lutz test. So this is actually in the installation purpose. This part has been already flat trot. The results is very satisfactory. So as a result, we see that prolonged operational life, less interruption to the operations, also less maintenance effort and less spare parts. In overall, the parts cycle life, the life cycle cost is reduced. Life cycle cost reduced significantly. So I hope these kind of examples give you some ideas how the parts can be turned up to be a value-add AM part. I would like to mention our collaborators. Previously, I mentioned NAMIC. We are continually working with NAMIC. And I also would like to acknowledge NYP, Nanyang Polytechnics, as well as US, who are the collaborators for us to achieve the YASA STC results. We also have other collaborators. Right now, we discuss with A-Star for our ICP project to bring our capabilities to the next level. This is not enough We also need to work with our OEMs and our collaborators to understand their machine to maximize the advantage in our applications. Other than that, material is another very important aspect. So we also work with the material OEMs to look into how can we bring in more value-add materials to our customers. Again, in order to complete the AM value chain, we will need a strong supply chain, which mainly consists of local SMEs. I have listed some of them over here. This is not all of them. We are looking forward to work with them continuously to bring our combined capability to the next level. So I would like to have a quick recap on the parts we have developed for the aircraft use. This picture summarizes the areas we have the parts. And the top is on the seats. We basically cover all range of the seats, different kind of parts. The bottom one consists of a monument group, which is the galleys and the lavatories, as well as the aircraft, the brackets and the ceiling outfits. At the same time, we do customized parts as well. For the freighter aircraft, the issue will be different because when the aircraft is going to be converted to a freighter aircraft, it's already have certain age, which implies obsolete part could be a potential issue. So over here, there are examples we are using AM to tackle the obsolete part issues. For example, exit sign, for example, the cargo door covers. So this can be quite handy with very short lead time, we are able to deliver them. In other areas, this is the housing example, which we awarded with the YASA STC. We also have the covers, like a lower kind of a complicated shape. Original part is made from many parts. Each of these strip is a sheet metal parts. It's assembled by many rivets. Whereas in our solution, we just put into one. We did not forget the lower hanging fruit, which is the tools, jigs, mock-up, and the prototype, where we don't have to do certification. This will be very quick turnaround projects. Over here, I feature a few. One of them is a complicated jigs. You can see it's very complicated. So this kind of jig is to use for high precision cutting on a complex contoured surface for sophisticated modifications. The other group is the middle one, which is used for the mock-up, also can be used for marketing as well as customer design review. Another area is the rapid prototype. We can do a quick fit check to improve our design, finalize the design. The bottom one is a quite interesting tool I wanted to briefly share with everybody. This one, the middle one, is a center finding. In our engineering drawings, we always take the center of the circle as a reference. However, in the production floor, there's a virtual point. Nobody can see that point. So how? Very difficult. With this tool, we are able to find the center easily with different diameters. After that, the technician can just use that center, line up whichever distance they need to control. Another one is on the right. When we have certain features on the connecting parts, we have to join them with certain alignment requirements. It's very difficult to achieve this with a bare hand. So we integrate this base plate, which mark with all the degrees, and also the indicator. By this way, the technician can easily mark out where is the alignment point to carry out their work. With this kind of tool, things can be done easier, faster, and more precise. So this is the advantage AM can offer. The other one is just a simple stand and the left bottom. You can see that this V block is able to adjust to suit for different sizes of the ducts. If you have different weight, you can use different pairs to put more or less. So it's very versatile to tackle different kind of this kind of objects in the modification and maintenance floor. We are very grateful to see our customers and collaborators the encouragement from the open source. So I just listed some over here. These are the jobs we accomplished with our various collaborators and customers. I would like to thank my team as well. No matter how good is the machine, no matter how good is the process, without people, we can't do anything, we can't move anywhere. So my team is just 6 of them together with me. However, we are doing a big range of the work. I have to see that within the ST engineering family, we are very fortunate. We have many people to support us, from the certification framework to production team, to the quality assurance team, as well as our MRO fronter team over the world. So they give us all the feedback, what to be done, what customers are looking for. Of course, we never forget our collaborators who supported us all the way. So we are looking forward to work with all of them, continue our journey. Now, we actually have a certain product range to be used for aircraft. We also have certain capabilities to work with any of you. You have any needs. We have the website, as I mentioned earlier. Please visit it to find out more details. You're welcome anytime to approach us for whichever problems, questions you may have. No obligation. All right, looking forward to work with all of you to build our combined capability. With this, I would like to thank you for your attention.
Thank you, Dr. Chen. I'm sure you'll get a lot of requests to meet you and the team at ST Engineering. So, and you've been really collaborating and with technology partners and like-minded customers to design, produce, and certify products using your robust AM solutions for wider use, and in particularly for the aviation industry. So now let's hear from our next speaker, Mr. Chai Hao-Nan from Additive Flight Solutions. Hao-Nan is currently General Manager of Additive Flight Solutions, a joint venture company between SIAC and Stratasys. He has taken over since July 2020 with about 15 years of experience in the aviation industry. Prior to this appointment, Hao-Nan has undertaken various roles with the aviation industry with the bulk under technical support capacity. Now, coupled with stints in fleet technical management and component engineering, he's deeply involved in aerospace, aftermarket parts, manufacturing, and repair and certification. His experience with airline operations helps in bridging the gap from design and engineering to application. With this expertise, Hao-Nan will be sharing on how customer requests and deep diving into gaps left by the traditional manufacturing supply chain, which AM can really fill. He will also highlight the versatility of AM materials for aerospace applications in tooling and the evolution of 3D printing materials, which widens the spectrum of AM possibilities. So let's hear from Hao-Nan. Hao-Nan, over to you.
Thanks, Mahendran. Welcome everyone to the webinar that is co-hosted by NAMIC and AAIS. So it's a pleasure to be invited to be speaking at this webinar. So without further ado, I will just go ahead with an introduction of the organization itself. So I'm actually part of AFS. So AFS is a joint venture between SIEC and Stratasys. So the JV actually plans to combine Stratasys' know-how in additive manufacturing with the comprehensive MRO knowledge at SIEC. So of course, as the name implies, Additive Flight Solutions was initially incorporated with a focus on cabin parts production, certified cabin parts production. So of course, with the evolution over time, with the wide-ranging applications in aerospace, in defense, and automotive and other industries in US and Europe, we have actually realized that there is a lot of other opportunities in design, engineering, and tooling to the other industrial segments such as maritime, automotive, etc. So in the next few slides, we will actually run through what are the key drivers that we have incorporated in the last year. So, okay, this is just a quick overview of AFS. So we are based at Loyang, which is near the aerospace cluster. So we focus on aerospace, MRO, and industries. But however, over the last few months, we have pivoted away to the other industries based on the applications available. So our platform for building is currently focused on the FDM technology, utilizing the Fortus 450. So we have just received our Fortus F900 and in preparation to induct it. So besides that, we have access to approximately 200 AM machines via the Stratasys Partner Network. So in terms of certification, we are leveraging on SIAC's EASA Part 21 approval for POA and DOA. So as for AFS itself, we are certified to ISO 9001 and AS9100. So our equipment consists of the FDM printers, as shown on the left, the F450 and F900. So in terms of quality control, there's a strong emphasis on the post-production, production tolerances and measurement services. So we've actually invested in CommScanner. And in terms of design engineering, these are the topology optimization software that we currently use. Of course, these are at the moment, and we are actually getting whatever is satisfying our requirements in the market. So as we mentioned earlier, based on the worldwide experience, we do find that there is a lot of materials and technology that are suitable for a lot of applications that are not really taken off in Singapore in terms of industrial requirements yet. But we do feel that after we have brought this in and we have visited a few of the aerospace companies and MROs, there is a great demand for these materials for their tooling, jigs and fixture needs in their market. So of course, our bread and butter is in certified aerospace cabin parts production. So that's why our Ultem 9085 is the certified aerospace material that we have used to print cabin parts for the Singapore Airlines Group. So actually, since incorporation from now 2018 to current, we have printed more than 5,000 cabin parts that are flying. So there will be some use cases later. So however, as we have seen, because of the pandemic and also because of the opportunities available, we have also focused a bit more on toolings for the MRO industry. But these toolings are not just limited to aerospace MROs. They are also applicable to other industrial applications which we have seen, and we will expand a bit later. So to all interested parties out there, we will also leave our contact and our website for us to visit, where there is a web shop that you can upload certain models to estimate the price, the print time, etc. So besides Ultem 9085 and Ultem 1010, the high heat resistant material which we have brought in initially, this material is very good for heat application that requires, for example, masking, plasma masking. We have used a lot of these in the engine MROs, where a typical masking application can reduce a lot of manual labor required to tape up the intricate areas, and also reduce the wastage of materials. So in terms of nylon 12 carbon fiber, this is widely used in the automotive industry, and as Mark shared earlier, in the boom production facilities being used in all the drill jigs, etc. This is a very strong and functional high strength material with low weight. So on top of that, we also have seen that the Antero material, which is a highly chemical resistant and also good ESD discharge properties. So these are being used in the US space and satellite defense. So even here in Singapore, we have found that a good application is on use on the aircraft paint window masking for paint applications. So they're actually able to withstand very strong corrosive chemical paint stripping material. So besides the main materials, we do have additional supplementary materials like TPU, which is also 3D printed. So this TPU is very useful in the sense that it provides a rubberized kind of sealing material for paint masking applications, and it integrates with the hard masking that we are actually printing currently on our machines. So we do feel that in terms of a 3D or AM solution, it requires some form of integration with various material types so that the functionality range is increased. So as mentioned earlier, we will touch on a little bit on cabin parts, but now we will focus a bit more on the tooling and engineering. So in some of the MRO shops that we visited in terms of avionics and electrical components, a lot of ESD materials is required. So this is actually available in our range of materials under the ABS ESD materials. So applications such as cable routing or even customized covers for test boxes for the old Boeing 747 fleet platform. So a lot of opportunities are present in using the ABS ESD material on these covers and the cable routing, which will provide good product ergonomic and performance improvement support. So as mentioned earlier, for the window masking, there is also an integrated use of the hard mask with handles and even vacuum suction incorporated as a tooling solution. So of course, that's the end product, but the initial stages that complements the AM is actually the scanning of the profile of the window and manufacturing of these prototypes for testing. So besides the 3D printing material, we also have a target frame, which is all 3D printed using the aerospace material as a target frame for optical scanning. So as we all know, for aviation parts, for precise measurement, we do not want to have the reference marker stickers all over the parts. That will be an issue if they're not removed entirely, or it may also affect the part quality itself at the end if it's not done properly. So with that, with a reference frame, we're actually able to perform accurate and precise scanning for the parts. So these are in-house designs that we have come up with utilizing the AM technology and know-how. So besides the parts on the aircraft itself or the engine shops, we found that there is a huge demand for specific engine covers. So these covers will be of various forms and geometry that used to be maybe just done with a traditional canvas sheet. But now this provides customized protection to the various engine section without having a very large footprint on the whole workable area. And it also allows different portions of the engine to be protected when some other sections are being worked on. So the advantages are those are highly customizable. There's no minimum order quantity, and we're able to integrate functionality in a simple design. So as mentioned earlier, we also have been doing a few plasma masking for the engine shops using the Ultem 1010 customized material for engine cross-sectional areas. And also in terms of wheel paint masking, we are using our own ABS material, but with the TPU rubber masking as an integrated solution to seal up the tight spots to prevent any paint seepage. Okay, so this is also overlapping with what Mark has shared earlier. So in terms of toolings and drill jigs and guides, so it is also widely used overseas in terms of the Ultem material for the trim guides. So we do not see this that much in the current Singapore application context, as we probably do not go very deeply into manufacturing of aircraft fuselage or the structural parts. But this could be potentially used in maybe other industries where there is a demand for the structural assembly and production. So besides the structural parts, there's, as mentioned earlier, in terms of automotive industry, there is also alignment jigs that are being used, printed in a nylon 12 carbon fiber. So this is what we usually bring around in our various shop and production floor visits to show that the material itself is a lot different from what we have imagined to what polymer 3D printed material can look and feel like. So of course, end-of-arm solutions for robotics, we do have grippers using nylon 12 carbon fiber. So the benefits is 40% lower weight, is higher stability due to nylon 12 carbon fiber, and in some applications where there is metallic surfaces, the plastic material grippers will actually not damage the contacting surface. So this is an expansion on the customized engine covers, where in areas that are difficult to access as a certain piece, we can actually print 4 to 6 different subsections of the cover, and we can have an integrated solution for grippers on the roll bars for the engine section tools. So now we just touch on a bit on certified parts production. As what Dr. Zheng mentioned earlier, so in terms of AM, is the main priority is not just to use reproduction of existing parts, but also to add strength to the original part. So for example, in terms of the cocktail tray replacement, there is some strengthener used in the joints for the cocktail trays when we actually print it. So this improves the reliability. And also for aircraft safety devices. So these are not standard parts, but is in addition to OEM requirements, the airline has a requirement for additional safety tools on grounds to prevent inadvertent deployment of slides. So these are safety features, door handles, covers that can be used to prevent the handles from being rotated. So finally, in terms of COVID situation where the repatriation flights need to be carried out, there's also demand for sanitizer holders, and we had this from design to certification to parts production within 2 weeks. So this will be an alleviation from any global supply chain shortage. So the last slide will be on design and engineering for AM. So as mentioned earlier, in terms of design and engineering, we have to actually see how to lower the cost for industrialization and parts production. So that removes material reduction. But again, at the same time, with analysis and design, we are able to strengthen the original part, so to make it a win-win situation. So with that, I've come to the end of the sharing. So of course, there is a lot more information on the website, and these are the contacts for the AFS. And we once again thank NAMIC and AAIS for inviting AFS to be part of this, and we look forward to further sharing with the rest of the participants. Thank you.
Thank you, Anand. Excellent sharing. A lot of insights that we found out through your presentation. And our final speaker today is Mr. Lu Weiyao, the co-founder and technical director of Flare Dynamics Private Limited. Flare Dynamics is an unmanned systems aerospace precision engineering company that provides bespoke, turnkey business-to-business unmanned systems solutions. By adhering to the company mantra, the purpose creates the machine, Weiyao and the Flare Dynamics team have been able to grow impressively in recent years, with focus in the security, defense, and law enforcement industries. As an engineer by training and by profession and by lifestyle as well, Weiyao is passionate about unmanned systems development and delivering the most objective and yet versatile solutions to his clients. Now with his passion, I'm sure Weiyao is thrilled to share with us what he has prepared for us. Over to you, Weiyao.
Thank you, Mahendran. All right, so good afternoon, everyone. I hope you can hear me. Thank you so much, NAMIC and AAIS, for the opportunity to represent the unmanned systems space in the region. So this is Flare Dynamics. My name is Weiyao. I'm the co-founder and technical director of Flare Dynamics. So like what Mahendran mentioned, we believe that the purpose creates the machine. There really isn't a purpose, or rather there really isn't a, if there's no purpose to something, there really isn't a point of creating it, right? So that's something that we live by every single day at Flare Dynamics. So Flare Dynamics is a precision aerospace engineering company that's founded by individuals from diverse engineering disciplines. We provide business to business and business to agency bespoke unmanned system solutions. So a little bit of what we do and what we create at Flare Dynamics. As you can see from the 6 icons that you have in front of you, Flare Dynamics creates both software as well as hardware in the unmanned system space. So ranging from advanced composite and hardware development, we design and create our own airframes, unmanned system software development that complements the usage and the operations of the hardware that we provide. We are very heavily into unmanned system services, very specialized unmanned system services in the inspection, monitoring, and defense space. We provide training systems and simulation to some of the tertiary institutions here in Singapore. General precision engineering, as well as actually unmanned system video analytics to allow our users to actually see what they want to see and make sense of what they want to see. So, is AM used in unmanned systems? Well, I would think very much so. Actually, there's extensive use of AM in modern unmanned aerial systems technology. And I would say AM is one of the largest disruptor, if not the largest disruptor, in the whole unmanned system space. So both are disruptive technologies. Both AM and drones are disruptive technologies, and they complement each other very, very, very well. So the employment of AM in unmanned aerial systems of UAS has allowed for a huge growth spurt in the innovation at all levels of industry. So just by judging on the graph that you see on the left, it shows you both the defense and civilian global aerial drone market all the way to 2023. So, and that's in billions of dollars. So you can see there's a huge market opportunity right there. So the unmanned aerial systems industry is growing at a pace which is otherwise unseen in any other space. And innovation in technology development as well as technology application allows for a myriad of different operating scenarios. So why are conventional techniques not ideal? Well, the use of conventional plastic molding techniques poses a challenge to basically three groups of people, right? Startup companies, very similar to like basically Flare Dynamics, prototyping and design firms, very much like Flare Dynamics, as well as low volume contract manufacturers, very much like Flare Dynamics as well. So we fall in that prime category to employ and leverage on AM technologies. So the key limitations of conventional plastic molding: initial capital investment, the need to create molds and similar componentry is very expensive to begin with. The large production area is normally required for the production of these parts. The slow time to market because of the need for revisions and iterations to the initial molding and molding equipment. High volume production outputs in order to amortize the cost of the initial capital investment, as well as in general design alterations after mold completion are somewhat limited when you actually need to modify your existing design or your initial design. So we believe that at the initial stages of engineering, there are three things that we think are very crucial to allow for a successful product, which is that we need to understand that the ideas do change along the entire design process. The concepts will need to be adapted as we move along, but more importantly, the designs have to morph and adapt and change in accordance to the different stages of engineering. So as such, it's actually highly favorable to adopt a manufacturing technique that, number one, permits and promotes an iterative design approach. Number two, it capitalizes on a radical and unconventional thinking. And number three, it actually leverages on the freedom of constant change at a minimal cost. So these three things are crucial in order to really provide or design a product that will be that is customer centric almost. So additive manufacturing promotes innovation. We at Flare Dynamics feel that there's no two ways about it, right? So, and innovation is key, especially for a technology company, be it disruptive technology to begin with. The pace in which things move is extremely fast. So innovation is key to provide that degree of that distinctive edge. So why is AM important? Well, we can take things from we can see things from two different perspectives. Number one, the managerial perspective, as well as the engineering perspective, right? So from the managerial perspective, it is ideal that there is a minimal cost impact for design iterations even after the initial prototype has been produced. Now, if we were to employ standard or conventional manufacturing techniques, the modifications to mold design, the production of a new mold, now these are extremely cost intensive. And additive manufacturing basically eliminates the entire process by means of allowing a lot of change with not a lot of money, which is very crucial, right? Coming from the engineering perspective, well, more optimized and objective mechanical designs with less critical considerations to manufacturing can be considered, in the sense that we do not need to really consider the limitations of conventional manufacturing techniques, but rather have a more objective-driven design approach, which is more optimized, be it for weight reduction, for strength to weight ratio, or other things that I will cover shortly. And of course, like I mentioned earlier, AM actually allows for a more effective idea generation process. So additive manufacturing provides a whole new dynamic, right, between three elements: designers, manufacturers, as well as end customers. Designers are better able to design components or products that have the customers in mind. And also the manufacturers are better able to produce these, I would say sometimes unorthodox designs, because AM allows you to do so, right? So by reducing the effort needed for design alteration and production of a customized solution, basically all three parties in the entire process chain would be able to benefit from AM. So a service bureau that we work very closely with Additive 3D Asia, which is a professional AM service bureau based in Singapore that provides both FDM, SLS, MJF, and a lot of other. So we work with them very closely, and they actually facilitate industries in automotive, aerospace, engineering, even production of spare parts in shipping and marine. And so the uploading of parts and parts assessment workflow is extremely efficient, I would say. And so special shout out to Jason and Pauline at Additive 3D Asia. So for I would say, being able to meet some of our extremely stringent requirements sometimes. So the AM revolution in unmanned systems is seen, like I mentioned, across the board, right? So an example of that is Parrot. Now, Parrot is a French-based global UAS firm that has utilized advanced SLS technology in the production of the Bebop 2 consumer drone chassis. And the purpose of that is in order to, number one, optimize the structural performance without developing long lead times and high cost injection tooling. Number two, accelerate the iteration generation process at the initial stages of design and also facilitate production in series, right? Now, bringing things a bit closer to home. Now, this is basically a case study on the challenges and solutions in creating the Discrete Eye Mark III micro UAS, which is a product of Flare Dynamics. So what exactly is the Mark III, the Discrete Eye Mark III? The Discrete Eye Mark III is an ultra lightweight tactical micro unmanned aerial system, which is about the size of your palm and weighs about 250 grams. Now, what exactly is 250 grams? If you were to go home, right, just before you brush your teeth tonight, take out a brand new tube of toothpaste. Now that is 250 grams. I'm assuming we all use Colgate or something along that line, but that's about 250 grams. So the Discrete Eye is normally deployed in close range tactical engagement scenarios, or what we call crates, where immediate intelligence, surveillance, and reconnaissance, or ISR, is required. So some of the challenges and solutions in creating the Discrete Eye Mark III. Now, the challenges can be subdivided into both engineering and organizational. So let's just look at engineering first, right? We have dimensions that we have to pay a lot of attention to. Weight, okay, is one of the of paramount importance in any drone, right? Impact absorption, which I will share a bit more later. The strength to weight ratio of our components, as well as the material properties of the material that is selected, right? So by considering all of these elements, we resulted in a concept that we need to basically employ a performance optimized design in order to achieve what we want to achieve with our end product. So if we move over to the right, to the organizational consideration, right? We identified that we needed a user-oriented design approach. Okay, that's because of the end users and how we can facilitate their growth together with Flare Dynamics. All right, there was a requirement for initial low rate production, right, in the beginning stages to identify some of the requirements of our customers as well. And there was a need for a phase-to-phase iteration approach, whereby after the first phase, there might be requirements to modify the design or enhance the design, and that's what we mean by phase-to-phase iteration. So as such, from the organizational perspective, we identified that we needed a very customized low-rate production approach. So these two things, performance optimized design, as well as the customized low-rate production, both culminated in the solution being the employment of additive manufacturing. So let's just look at the size requirement of the Discrete Eye. So like I mentioned, the size of the Discrete Eye is about the size of your palm. Right, so it is a micro-sized platform in order for it to be tactical and easily deployable. And as the name suggests, the smaller the aircraft, the more likely it is to be discrete. Right, so that was the design intention. So another thing that we needed to consider is that a micro-sized platform has micro-sized subsystem components, be your electronics for navigation or for power distribution, so on and so forth. So the resolution of AM is really crucial to attain these mechanical properties as well as aesthetics. Moving on to the weight consideration, like I mentioned, the all-up weight of the Discrete Eye is about 250 grams. So this ultra lightweight platform was designed because Anything under 250 grams, coupled with the safety cage structure that I will showcase later, poses no threat to personnel safety on the ground, right? So the additive manufacturing design and material must cater to these weight optimizations because it was a stringent requirement to keep the entire aircraft under 250 grams, which is extremely tall order. Now, the impact absorption characteristics of the discrete eye is what sets it aside from a lot of other drones of the same size or capability. Now, the discrete eye system has an exoskeletal impact safe shroud system, right? So basically what that means is coupled with the 250 gram all-up weight, the aircraft can drop out of the sky, right, essentially, on an individual and have no threat to personal safety whatsoever. So the ultra lightweight platform with the impact absorption characteristics pose no threat to personal safety. So the AM design and material must cater to that rigidity yet flexibility ratios. The rigidity and flexibility ratio is something that has to be considered in order to get a rigid structure, in order for, say, good flight characteristics, but still be flexible enough in order to take in the shocks of an impact. So the incorporation of enhanced cross-sectional designs to attain rigidity and flexibility was employed. So as we move along the entire or the different cross-sections of the entire exoskeleton, there's actually a variation of the cross-sectional types and directions. So this was done in order to really maximize the weight reduction of the entire assembly. So basically, additive manufacturing was the only thing that permitted us to build in multiple directions. Now, how safe is the discrete eye? Now, just to give you some quantification of values, right? In front of you will see that there's a term called HIC. Now, HIC stands for Head Impact Criterion. Now, for you to get any for you to get an 18% chance or 18% probability of any form of a concussion, the HIC has to be 1,000. The discrete eye, through our analysis and empirical study, has an HIC of anything between 1.06 to 1.52. So it's literally a fraction of what you could probably get by a concussion, essentially, which is 1,000, right? So it's a fraction of that. Now, the strength to weight ratio is crucial for the discrete eye as well. Okay, so all components are designed with weight reduction as the primary emphasis. Weight optimized designs do not permit the use of conventional manufacturing, and non-injection molding friendly features such as undercuts, deep drawn sections, internal voids, varying wall thicknesses are all employed, and these are things that only AM allows for manufacturing. So what challenges are still present? Well, AM material mechanical properties, depending on the material and depending on the manufacturing technique, is still there's still certain shortcomings when compared to injection molding, right? If you don't get the manufacturing techniques right or tuned, you do have the chance of deformation and warping as well. The end product surface finishing, I would say that there's still work to be done on the end product surface finishing as well. And of course, the production output volume, whereby the production speed is basically governed by your print bed area as well as your print speed. So these are things that we see that in the last couple of years, there has been a huge improvement and enhancement in the entire AM space, which are really addressing these problems very, very objectively. So in order to approach, we have identified these few steps that would allow us to really be objective in our designs. Number one, know the performance requirements of your product. Number two, identify that AM is the correct manufacturing option for you. Number three, select the material and AM type, be it FDM, SLS, MJF, and so forth. Number four, adopt an AM-oriented design approach. Number five, produce with AM. And then lastly, number six, test, validate, and deliver your product. So in summary, additive manufacturing designs are not optimized for injection molding and vice versa. So as such, it is key to identify the manufacturing processes, prior to any design work to really prevent any major redesign and delay. Additive manufacturing opens an entirely new avenue for innovation, and these innovations are completely changing the perspective of how unmanned systems are designed, developed, produced, and utilized. And we feel at Flare Dynamics, we feel that AM will play a pivotal role in the unmanned systems industry. And thank you so much for your time. I really appreciate it. Thank you.
Yeah, thank you so much. That was really very insightful. Good for us to find out all that's happening at Flare Dynamics. Now, as we kick off our panel discussion, I'd like to invite you, the audience, to leave your questions. I think there's been quite a few questions that have been posted, but please continue posting them, and we'll be answering them as we go along the panel discussion. So I would now like to invite our moderator for this panel discussion, and Mr. Sia, please welcome back and take over from here. Thank you.
Thanks, Mahendran. Thank you, everyone, for your cooperation, and thank you also for those who have posted some questions up there. We'll get straight to it, perhaps starting with questions relating to ST, if I may. First of all, Dr. Cheng, I really must appreciate how you acknowledge the contributions of your team, as well as the support of various organizations. And I think this reflects an important point that we're making in this webinar, that it takes an ecosystem, right? In order to bring us to where we need to be. It's analogous to the saying that, you know, it takes a village to raise a child. Okay, so there was a question earlier posed for Dr. Cheng. And that relates to your YASA certification. You know, that's really very important for aerospace. Can you share with us a little bit about that journey to achieving that YASA certification, and what were some of the important learning points you'd like to highlight to the rest of the audience here?
Sure. Indeed, it's very important milestone, and then not only our capability, indeed it's a Singapore capability, because which involve numbers of our collaborators. Okay, the hurdles I will summarize into 4 areas. The first area is definition of the EM process, because when we certify something, we have to qualify the manufacturing systems first. In order to qualify the manufacturing systems, we need to define how do we utilize it to produce the part that we term as processes specification. EM is a highly customized manufacturing method. There are 100 parameters you can change. There are also raw materials, how do you accept it? And then there are post-processing, how do you do it? All this can be a contributing factor to your part performance. Ultimately, the regulators look at the safety aspects. How are we going to be sure the safety is not compromised? So the first hurdle is to define the process. How fine? How do we choose the parameters? So this is the first thing. Then that actually is a combination of know-how of aerospace requirement plus additive manufacturing knowledge. The second part is the how to demonstrate the processes. After we define the process, after the regulators review through, they feel somewhat is sufficiently defined, sufficiently controlled by the process parameters control. Now they're happy. You can go ahead to show us how robust is your process, right? So how are we going to demonstrate? You know, when we build our parts, the parts has different geometries, different orientation, different thickness, different loads requirements, different critical points. How are we going to demonstrate that process is able to achieve the desired or the required, the threshold to guard safety, right? So that is carefully designed. We call it campaign to showing the process robustness, which lead to a qualification of that process. So this is the second part. The third part is talk about the supplier management. AM is so new. There's so many parameters. Even your print orientation can affect the outcome. So our design is not stopped at the engineering drawing, but build drawings, right? So the orientation do play a part. Then the regulators do have a concern. If you have the same CAD model, how are you going to be sure whichever print it will have the same outcome? How do you control it? That's the supplier control. So that one, we actually done a lot of procedures, a lot of controls. So indeed, we are controlling the build file, which already spell out how the orientation, how the support being designed. The last part is the quality control. We already, if let's say we already qualified the process, we already done the prototype, we already certified the part. Now move to production. How actually going to inspect the parts, making sure the parts meeting the original intended design requirements. So this the last part of this, the certification process. So in short, these 4 areas are the main hurdles we actually encountered. Yeah, we are very, very proud. We managed to manage it through. We learned, we built, we showed. Yeah. Thank you.
Congratulations, Dr. Zheng and team. In fact, I remember listening to your presentation. It was probably 2-3 years ago, and I can see so much progress since then, and that's really a testimony to your very systematic approach. I took notes of the 4 points, as I'm sure many of our audience did today. Now, if I may swing the attention to Hao Nan, thanks so much also for sharing. And again, the last time I heard AFS presentation, compared to that, you've now added a whole new area with respect to tooling. In addition, of course, the breadth of parts that you produce. And it was interesting to hear you say that you've got something like 5,000 pieces somewhere flying. And that's quite an impressive track record. Now, what is this process by which you engage customers to define their requirements and then ultimately to develop the solutions? What is that entire process that you walk the customer through and internally within your organization?
Okay, so far we've been quite privileged and lucky to be invited to a few of the aerospace MRO shop floors. So what we see is that a lot of the conventional tooling, either due to the aircraft fleet obsolescence or due to new requirements and ideas by the production shop floor to improve on the OEM designs. So based on the opportunities that they highlighted, we have a bit of technology or know-how on the design for AM and what is possible and what is more suited for conventional manufacturing. So we actually do a shop floor visit and try to understand the problem. We do a scan, and then after which we do a proposal and a 3D drawing with a price estimation. Because on our end, we do realize that a lot of the shops are very cost conscious. So there is always this element of design cost versus the replacement of the existing part. So if it's not cheaper and better, we technically deem it as a no-go. So in the whole evaluation process, we typically take about 3 days to a week to come up with the scan, the estimated pricing. And once the actual design has been finalized based on the business case, we actually do print a small trial section for fitment, and in some cases, maybe a bigger prototype. So all in all, a project itself takes about 2 weeks from understanding the problem statement to coming up with a business case and design. So we try to do it right up front in terms of the business case analysis. And of course, having said that, each of these projects are actually stocked up in our own portfolio. So when we do visit other factories or production facilities, the same opportunity is presented to the guy there, where the existing solution may be evaluated on a different basis. So technically, this is how we approach on a face-to-face basis. So we do understand that there are some platforms that actually does the automated sort of part selection process. But for now, we still do it on a physical interaction basis. And it technically takes about 2 weeks. Yeah.
Well, that's quite an impressive timeline. May I just do a quick check with you as well? If some of these solutions are customized and co-developed with your customers, because they may first broach the idea that something is needed there of this kind of concept. How do you then share the intellectual property? How is that dealt with?
Okay, so whatever we do currently, what we are doing is more on existing tooling rather than the OEM design tooling. So in terms of the design, it's actually quite generic and it does not involve, or rather in terms of, let's say, an engine manufacturer, the customized geometry is sort of applicable to only their geometry that they require. So technically, that technology, that exact part of design can't really be used for another company. But the idea and concept is being broached, and then we do a physical scan with the approval of the new customer. So that's how the design is then developed. So to be frank, all our designs are not really like rocket science or like innovative breakthroughs, but they are usable shop floor improvement parts that we think that besides those trademark AM projects, we do feel that there's a place for it in the everyday product development and improvement process.
No, I like that very much. The idea that technology can be applied to everyday problems and achieve an improvement in productivity. There are many little projects, some not so little, but which can make a difference collectively. And that's the daily life of a shop floor engineer, I'm sure. I'm not sure if we've also in the process addressed this question by Rachel about time frame and considerations for incorporation of AM for tool fixtures manufacturing. Rachel, if you're somewhere out there, perhaps you can let us know if you need to follow on more on this question or we've adequately covered it. Okay, you can also just type it into the chat and we'll revisit this. But let me go on to Wei Yao next. Wei Yao, I'm really happy that we've been able to have you on board to share today because we have a growing UAS community within our association with 40 over organizations now. And right. Having you speak is is wonderful because it really reflects the burgeoning opportunities and excitement over unmanned technologies, and to learn that AM is such a key role to play. I myself was a tool and die and mold engineer years back, and so I really appreciate what you say, about the value that AM can bring. Now there's some questions here for you. Let me sort of digest and pick that out. Perhaps one point here is to do with how reliant you are on the production of structural components for your drones in using AM. And, I think you've sort of said so, but you might want to elaborate on the extent to which you're using AM for the, to displace conventional manufacturing techniques.
Right. So the extent on how reliant we are on AM actually varies with regards to some of the different products and the different product lines. And the reason why it varies is also you pick that sweet spot, right? Where AM we are able to really leverage on the performance of some of the materials and what AM can provide. So because we use a lot of carbon fiber in our manufacturing of airframes, we have seen that for the manufacturing of very small airframes, right, whereby weight is of paramount importance, you need something that's extremely small, robust, and rigid. We feel that AM is really the way to go, and it's really the way to go long term. It's not just at the prototyping stage anymore. It's really all the way to the end product. It's because, like I mentioned earlier, right, there are really some things that you just cannot produce with conventional manufacturing techniques. And if really every single gram counts sometimes, or even half a gram counts, right? So that's where I would say in the small aircraft space or the small UAS space, anything under say 1 kilogram, I would say we use 70% of the entire airframe is actually AM, just to put things into some numbers, right? So how reliant are we? Yes, we are extremely reliant on AM. We have decided to go down that path whereby we have decided to say that AM is the way to go, and that's what we have been walking along that path all the while, and will continue to do so for a long time coming. right? So yeah, so that's how reliant we are on AM actually.
Okay, thank you for that. So we've heard a little bit from each of the speakers, and I'm also wondering whether Mark, you might have some either questions or comments to offer.
Yeah, so thanks a lot for the panel discussion. Probably just a follow-up question with Wei Yao. On the parts that are designed and fabricated by Flare Dynamics, are you able to share how this, how AM as a technology actually help you with the inventory planning and also the storage cost per se?
I think it resonates. I think this question also resonates with Dr. Zheng and Honan as well, right? Whereby with you really do not need to really keep stock of a lot of different parts anymore. There really isn't a need to, because we are not limited by MOQs. We're not limited by minimum order quantities anymore. And for an SME like ourselves, that's extremely important, whereby if we do not need to keep inventories for all the different parts that we produce or all the different parts that we provide, then it's almost to a point whereby we can actually resonate with the just-in-time manufacturing or just-in-time manufacturing approach that some of the larger organizations use. And using AM allows you to do that, right? Using conventional manufacturing techniques, not so much, right? Because of the economies of scale. So that, coming back to the question, I think AM has really empowered many organizations around the world with the capability to not hold a lot of parts, but still be able to provide the parts on demand in a short amount of time. Now that's really crucial.
Then for the case of drones, for example, when you design something, how do you do the qualification? Is there some kind of CAAS qualification process that you need to go through?
At the current juncture, no. Okay, so at the current juncture, CAS is concerned with, say, how you safely operate your drones, or whether your drones are, say, airworthy, right? So that I think globally, there are certain standards that are gradually rolling out, very similar to the aerospace industry in general. And we will see this, I would say, in the next 2 or 3 years, whereby manufacturing standards will be imposed on certain groups of drones for certain kind of applications. So you will see this very, very shortly, I would say, yes.
Thanks a lot. Yeah, I think it's quite a game changer for you.
Yeah.
Yeah, and I have maybe a question for Hao Nan, because just now Hao Nan mentioned about the masking that has been created for spray painting. Are you able to elaborate a bit about how this Ultem mask actually help to increase the turnaround time?
Okay, so in the past, a lot of the applications in terms of paint masking and even plasma spray, they are manually done at the shop floor. So maybe there's a team of 3 to 5 technicians just doing the masking physically, and then that takes about half a day to 1 day. And then after the whole process is done, they actually remove it physically as well. So there is a lot of material wastage and labor involved in this others task of deep masking. So the one-piece hard mask is actually meant to mask out the bigger areas that will eliminate all this masking material required. So of course, having said that, some shops, they still do a single layer of tape masking, but the time is much reduced. So we do realize that in terms of that, there's a lot of labor reduction and material as well. So the mask is also reusable for various components. So typically the masks, they are able to last as of now up to a year or so. We haven't been seeing any replacements. So in terms of temperature wise, they're able to withstand up to 260 degrees Celsius for now for the Ultem 10.
So for the Ultem, it's possible to use for plasma spray or HVOF, right?
Yep, that's right.
Okay, that's very interesting, because I, from my recollection previously when I was in the aerospace industry, that the storage cost for this masking is always a huge issue, because when you keep it in storage, where do you keep it and how long do you keep it? It's always a cost. And I think this digital inventory will greatly enable the reduction of this cost and being able to print it on demand, because there are some cases where, for example, let's say there's a certain APU that doesn't come in so often, and suddenly it appears. All you need to do is just generate a something from the digital library to create that masking, isn't it?
Yep, that's right. And it can be printed on demand. Yeah.
It's extremely versatile. Yeah. Thanks. And maybe a question to Dr. Cheng. Yeah, thanks for sharing on the availability of how you use AM to design some of the fixtures and everything that you have used your qualified process to begin with. So is there a mantra where if there's a new equipment, you already have a certain workflow to process this if a new customer comes over and approach ST Engineering? Dr. Chen, you are muted.
Sorry, you're basically asking, is there any new inquiries? Huh?
No, so if a new inquiry comes in, so you have a ready workflow to create these fixtures to install, let's say on A320, for example. So maybe you can describe to us about this process.
Okay. I think you refer to the aircraft parts, not the tool sticks, right? So
yeah, aircraft parts, that's right.
Yeah,
so like for example, installing
we already, correct. If let's say we already have parts already certified and installed, if there's a similar requirements comes in, basically we can do it within the similar scope of work by the previous established recognition. For example, for the YASA STC, whichever scope within that STC, we have the privilege approve ourselves. Yeah. Is that clear enough?
Yeah, that's great. Thanks. Can you anything else from you?
Okay, there's a bunch of questions in the chat. What I'd suggest is that we won't be able to cover all of them, and Namik later can consider how we can get responses back maybe to the participants. But there is one there that I thought is worth mentioning, this thing about the HIC index, and is CAS requesting this for approval? This is for Wei Yao.
Yeah, actually HIC is not being requested by CAS. It's actually not, okay. I would think from our research, it's not really requested by a lot of, in fact, all of the global regulatory agencies. But how there was, at least from our perspective, right? How do we validate how safe our products are, right? I can say that our products are safe, but how safe? So if safety is of the paramount concern with regards to producing that particular product, then we needed some form of a quantification to allow to do so. And that's where we brought up the whole HIC, the head impact criterion. Now, the head impact criterion is actually a criterion used in the automotive industry during crash tests. So that's how they validate whether your seatbelts are working or whether your airbag is reducing the amount of G's upon a particular impact. So that's how they actually measure the automotive crash, or rather how they measure crash in the automotive crash test industry. So we felt that was extremely applicable in this sense also, because it is a drone falling out of the sky is a projectile falling on your head, right? So it resonates on both fronts, and that's how we approach the entire design of the discrete eye with the HIC as the backbone for the design intent. That's right.
Very good. Thank you for.
So I think you just jogged my memory about another question. I think I left out for Hao Nan. A question to Hao Nan. So I understand now that you are approaching more to industry directly. Is there some kind of service that you are providing to enable this B2C approach?
Okay, so technically we are mainly still targeting industries, but in our website we do have a provision for a web shop. So we do realize that a lot of applications, besides the companies that are using their personal designers, that may want to incorporate these 3D printed components in their overall bigger projects. So there is a web shop available for even individuals to upload their models into the for calculation of build time, estimated pricing, and etc. So with this, we can technically reach out and engage the individual consumers.
Okay, great. Thanks. Sorry, King Yok, back to you.
Thanks, Mark. Thank you. Maybe one final question that I'll pick up from the chat, and that's asking about skills. relating to the AM sector. I don't think there are necessarily a specific set of skills specific to aerospace, but rather the AM skills apply across all sectors. And maybe this is best responded to by NAMIC, which is also looking, I believe, at the skill sets required to support the growth of AM.
Maybe I can help to augment this question in terms of the answer. So I think as part of the plans on the framework, downstream, we will be working with the various institutions who have specialized knowledge for the various levels. Hopefully there can be a unified, let's say a certification such that either is it at a technician level, managerial level, and even specific to the sector. We hope to have this downstream recognition where we could help professionals to be developed for the industry. And it will be extremely attractive for companies which are already adopting AM to come to Singapore.
Okay, thanks, Mark, for that. I think with that note, shall I suggest that we close our panel discussions? And if there are questions that are unanswered or which you would still like to pose, there is an email address that you can write to, and I assume the response will be sent back to you also by email. Where is that found? I believe I saw it just now. It's marketing@namic.sg. Okay, marketing@namic.sg. That would be where you can pose additional questions. So back to you, Mahendran.
Thank you, Mr. Seah. Thank you, panelists, Rayao, Hao-Nan, Mark, Dr. Tseng. Was a wonderful session today. And thank you everyone who is here, who stayed all the way to the end, for joining us on this Thursday afternoon. So our session is now drawing to a close, and you've heard all about the open grant call for parts analysis and design for AM program. So do look out for it and start putting your thinking hats on and try to come and participate in this program. And you may contact my colleague, Hui Chi, via her email on the screen. And if you are interested in finding out more about our NAMIC events, do look out for our marketing collaterals and send us any of your inquiries and further questions also. So have a pleasant afternoon and have a nice rest of the day. And this is Mahendran. And on behalf of the team that put this together, a big thank you to all of you. Bye for now.